In this video, we're going to look at the pathophysiology of emphysema. Now, emphysema is characterized by the destruction of the alveoli through the breakdown of elastic fibers by proteases secreted by immune cells. So let's have a look at the pathophysiology. So here we have a man, and he has lungs with emphysema. He is a heavy smoker, which is the main cause of emphysema. So let's zoom into his lungs. We can see that his alveoli are affected, severely affected. Here we see destruction of the alveoli, its walls and elastic fibers, mainly by proteases, which are chemicals secreted by immune cells. So let us begin first by looking at a normal alveoli and see how it progresses to an alveoli of emphysema. So here we have the bronchioles, the alveoli, made up of many alveolus. And here we have the elastic fibers, which are found on the alveoli and on the bronchioles. The elastic fibers allow recoiling to occur during inhalation and exhalation of gases. So let us zoom into only one alveolus. Here's one alveolus. Here we can find elastic fibers, epithelial cells, and surfactant cells. Within the alveolus, we can find alveolar macrophages that has a role in cleaning up the alveolus and protecting it during infections or against infections. Here we have the blood supply to each of the alveoluses, essentially, and they contain red blood cells. Essentially, oxygen will be exchanged for carbon dioxide here, if you remember. Now, what essentially happens is that normally the alveolus will secrete anti-proteases, which will essentially protect it against protease activity. So usually there's a balance between anti-protease and protease. Protease essentially cause destruction or damage, and anti-protease will prevent this from occurring. Emphysema is caused by the imbalance between anti-protease and protease activity. So if there's more protease activity, there will be more damage. Just remember that. So let's draw another diagram. Now, in most people, the slow process of destruction of the alveoli, the elastic fibers, is initiated through the inhalation of toxins, such as cigarettes or from air pollution. So, cigarettes and air pollution contain oxidative toxins, which, if inhaled in considerable amounts, will have devastating consequences. These reactive oxidative toxins will essentially initiate an immune response and inflammatory response. Remember that alveolar macrophages are normally found within the alveolus. So exposure to these toxins from cigarettes will cause these macrophages to begin secreting many inflammatory mediators, inflammatory cytokines, mainly interleukin 6, interleukin 8, interleukin 1, TNF-alpha, and leukotriene B4. Now, what they will do is essentially these chemicals will enhance the immune response. For example, interleukin 1 and TNF-alpha can recruit neutrophils into the area, a process known as chemotaxis. So here we can see more neutrophils coming into the area. The neutrophils will actually begin secreting proteases, mainly elastase, which will begin destroying the elastic fibers. Not only this, but the macrophage also secretes other chemicals such as metalloproteases, which is another type of protease, which causes damage to the tissues there. So there's all these chemicals being secreted around this area from the immune cells, the neutrophils and the macrophages, which will essentially aggravate the area, causing damage to the surrounding tissue. So again, the neutrophils and macrophages macrophages are the main producers of proteases. The main proteases, remember, is elastase and matrix metalloproteinase. So the elastase will cause destruction of the elastic fibers, like so. And the proteases will also damage the tissues, especially the metalloproteases. So this whole response is sort of continuing through the inhalation of toxins. So the neutrophils are secreting elastase, the macrophages are still secreting cytokines, which will recruit more immune cells. As well, we not only see neutrophils and macrophages, there will be also T lymphocytes coming into the area. The T lymphocytes will also destroy tissue, possibly through T cell mediated apoptosis. So the T cells will tell the tissues to basically kill itself. After some time, we also see collagen deposition, possible fibrosis. Now, from this diagram, we can see that in an emphysema type situation, we see a lot of protease activity. And so we can see that there is an imbalance between protease activity and anti-protease activity, being protease having a much more substantial role. And all this is the result of inhalation of toxins such as from cigarette, which will create this sort of immune response. But remember, this diagram I'm drawing up now is not, normally emphysema does not occur step by step as what I'm showing. So you got to keep this in mind. Now in the lungs, normally, one of the main anti-protease in the lungs is alpha antitrypsin. However, some people suffer from alpha antitrypsin deficiency. Therefore, they are more susceptible to get emphysema because there's no anti-protease activity. I hope this makes sense. So, as we can see through this diagram, the pathophysiology of emphysema is the result of the imbalance between protease and anti-protease activity, with it being more protease activity. Now let's look at another thing called air trapping, which occurs a lot in emphysema. Air trapping is essentially when we breathe air in and it becomes trapped, and it's very difficult to breathe out, essentially exhale. To understand the mechanism behind this, we need to see the normal lungs first. So here we have the normal alveolus that will expand during inhalation of air. The elastic fibers will allow the alveolus to expand when we breathe in. And then during exhalation, the alveolus will essentially deflate. This is because of the recoil of the elastic fibers, big to small. And so during exhalation, air will flow out easily. Hope that makes sense. Now let's look at lungs with emphysema. So during inhalation, the alveolus is able to expand with force. And this has to be with force because there's no elastic fibers, because they are destroyed, remember? Also, the loss of elasticity in the bronchioles will cause the bronchioles to become more narrower during inhalation. So then during exhalation, the narrowing of the bronchiole and the absence of a recoil system because of the destruction of the elastic fibers will cause air to be trapped, making it hard to breathe out. So I hope that makes sense. So to summarize, in a person with emphysema, air can be trapped within the alveoli. The destruction of the elastic fibers will reduce recoil of airways, and so it is difficult to breathe out. I hope you enjoyed this video on the pathophysiology of emphysema. Thank you for watching. The next video will look at the treatments.